PowerPoint, we're talking more about the bacteria associated with periodontal infections. So, characteristics of bacteria. Structure of the bacterial cell membrane. Well, let's break it down. You have a cell membrane, which is a tough protective layer that encloses the bacteria. Its composition is important because it helps us identify what kind of bacteria it is. We use gram staining to help us identify bacteria. So, bacteria comes in two different forms, gram-positive and gram-negative. And we know what kind of bacteria it is based on their cell wall. So that's why the cell membrane is so important. Gram staining, again, reveals differences in the chemical and physical properties of bacteria, cell membranes. Cell membranes appear either purple or red after they're gram stained. So, gram-positive bacteria, positive equals purple. Gram-positive bacteria will stain purple. It's single and it's a thick cell membrane. This is associated with periodontal health. Gram-positive is friendly. That's why there's a plus sign. You can also think purple is the color of dentistry, so purple equals pro-dental health. Gram-positive is a good thing. Purple. Gram-negative. Gram-negative is bacteria stains red. So red is red as a bad color. So gram-negative bacteria have double cell membranes. They also play an important role in periodontitis. They're associated with periodontal infections. So again, gram-negative bacteria is red, and red is a scary, strong color. So gram-negative is scary, strong bacteria, bad bacteria. So here's a little more in depth about that. Again, you have gram-positive, which is friendly bacteria, and gram-negative, which is red, bad bacteria. Now, gram-negative bacteria, they are scary because they have little propellers, such as flagella, and they can move themselves around. They're mobile. Their cell wall is also composed of LPS, which triggers an immune response, which is, LPS is lipopolysaccharides, I think, something like that. LPS itself is not really associated with gram-positive, it's only associated with gram-negative. So, gram-positive, purple bacteria, friendly, it's nice, doesn't move around. Gram-negative, it's red bacteria, it's mean, scary, it can move itself around because it has flagella. And it also has a cell wall made up of LPS, which triggers an immune response. Alright, now the bacteria and the way it responds to oxygen. So you have aerobic bacteria. Aerobic bacteria requires oxygen to live. It needs to be in an area of the mouth where there's oxygen present. Such as, just on the teeth or on the tongue in the oral cavity. And then you have anaerobic bacteria. Anaerobic cannot live in the presence of oxygen. It's anaerobic. The word aero means oxygen. Anaerobic means antioxygen. Cannot live in the presence of oxygen. So in the mouth, anaerobic bacteria will be deep in pockets where there's not a lot of air. And so a good little side note is when you use your ultrasonic, your little micro bursts of air can shoot oxygen in those pockets and kill them off. Because again, they cannot live where oxygen is around. So, aerobic requires oxygen. Anaerobic, no oxygen allowed. Facultative anaerobic. These can exist with or without oxygen. So they're kind of like double agents. They can be, in the mouth, on the tongue, on the teeth, but they can also be in the pockets. Alright, medically significant biofilms. Medical and dental implants, contact lens. Oh, okay, I see what this is saying. So these are areas where you can develop a biofilm. You could have them on dental implants or implants in your body, contact lens cases, pacemakers, artificial joints, and teeth. When the bacteria mass gets to a certain point, they start to communicate with each other and become so densely packed that they need to be mechanically lifted or removed. Example, when you have flowers in a vase and the flowers sit in that water for so long, and then you dump out the water and there's a film left on the glass of the vase, that is a biofilm. Same thing happens in our mouths. So, biofilm-induced disease. 60% of disease may be biofilm-induced. Tuberculosis, cystic fibrosis, subacute bacterial endocarditis, and perio. You also have Legionnaire's disease, which was a bacterial film that they found in the air conditioning that killed a lot of people in a hotel. But let's talk about which bacteria can colonize the mouth. So that's a trick question because 700 different bacteria species and subspecies are seen in the mouth. So how do you know which ones are affecting you in disease? So we're going to look at bacteria associated with specific periodontal states. All right. So 76% of the bacteria in a mouth can be gram-positive, facultative rods, and cocci. Most are non-motile or non-moving. And again, that's because gram-positive is non-moving. So most of the bacteria in the mouth is friendly bacteria that doesn't move, that can live in both oxygen and non-oxygen places. So basically, I'm going to summarize that again so it makes sense. 3/4 of the bacteria in a healthy pocket is friendly, healthy bacteria that's non-moving and not pathogenic. So then you have different shapes of bacteria. You have rod shape, which is bacilli, and circular shape, which is cocci or whatever. Both of these shapes are non-moving bacteria. All right, now we're going to talk about the stages of disease and what kind of bacteria will be in those stages. So, bacteria associated with gingivitis. Bacteria in chronic gingivitis is 50% gram-positive and 50% gram-negative. So gingivitis is half and half. Half friendly bacteria, half bad bacteria. Gram-negative rods, in particular, will make up 40% of the bacteria found in gingivitis. So yeah, 50-40, 50-50, same kind of thing. So then you have periodontitis. Now, periodontitis is associated with an enormous number of bacteria. You have way more bacteria in the mouth going on in perio than you do in a healthy mouth, obviously. Chronic periodontitis is associated with a lot of gram-negative and movable bacteria. That makes sense. Gram-negative is the bad bacteria. So yes, in periodontitis you're going to see bad bacteria. Also, you're going to see moving bacteria because moving bacteria is bad, we know, and it is how perio moves from tooth to tooth in the mouth. So here's some charts going over bacteria in a healthy mouth versus bacteria in disease. So in health, you have mostly positive cocci, mostly positive rods. And again, positive bacteria is friendly and good. And then you have just a little bit of negative rods and a little bit of you have more aerobic and less anaerobic in a healthy mouth. So in gingivitis, you have almost half anaerobic and almost half aerobic bacteria. And then in periodontitis, you have mostly anaerobic, which makes sense. Most of the bacteria is deep in the pockets. In periodontitis, the bacterial composition differs significantly from patient to patient. So the types of bacteria in the mouth can differ, but we know in periodontitis, either way, it has more bad bacteria than in a healthy mouth. Current suspected periodontal pathogens. So these are the specific names of the bacteria associated with periodontal area, the periodontal area. So for periodontal pathogens, you have 4 major ones. You have AA, or Agridophobacter actinomycetimicans. I don't know. AA. And then you have Tannerella forsythia, TF, Tannerella forsythia, Fusobacterium nucleatum, FN, and Polyporphyromonas gingivalis, PG. Or like Miss Alexa likes to say, Porphyromonas gingivalis. Those are periodontal pathogens. So let's go into depth with these 4. AA, or Agridophobacter actinomycetimicans. Hope I said that right. Excuse me. This bacteria is strongly associated with perio. It's capable of evading normal host immune response. It can destroy gingival connective tissue and bone. So AA is associated with things that are more refractory in nature, such as grade C patients. AA is not seen in gingivitis. AA is seen in periodontitis. Okay? So AA, I want you to think of when you hear like people saying, I'm going to my AA meeting, like Alcoholics Anonymous. That's bad, right? That's a bad meeting. So this bacteria is bad in perio. This is what it looks like, a little pretty star shape. Tannerella forsythia. Tannerella forsythia is the most significant risk factor that distinguishes individuals with perio from those who are healthy. It's the most common species detected in epithelial cells from a perio pocket. So basically, in summary, if you swab a perio pocket and you see Tannerella, you know this person most likely has periodontal disease because it's the most significant risk factor. This one, however, can be seen in gingivitis as well. Usually it shows up at the gingivitis perio conversion point. So if you see a patient and they used to have gingivitis, but now they're being swabbed for Tannerella, you know they're probably going to end up being a periodontal patient later. Alright, FN, Fusobacterium nucleatum. This is friendly bacteria. But it can easily co-aggregate with other bad bacteria. It's found in high concentrations of low birth weight babies. So this is, like I said, it's a friendly bacteria that's in the mouth usually, but when it's in the mouth in increased numbers, it can be bad. Why is that? Well, Fusobacterium has a lot of friends. Fuso, friends. F and F, right? Excuse me. Fusobacteria, when there's a lot of it in the mouth, can bring its friends, good friends and bad friends. But once it starts bringing its bad friends, it promotes biofilm maturation or coaggregation of biofilm. That's when you have normal pellicle on the tooth, and then the middlemen bacteria or the friendly bacteria who bring their bad friends, and now you have bad bacteria coaggregation on the tooth. So, Fusobacteria nucleatum is associated with NUG and NUP, necrotizing ulcerative gingivitis, and necrotizing ulcerative periodontitis. All right. Porphyromonas gingivalis. This is found in low numbers of health and gingivitis. It's more frequently in aggressive forms of periodontitis. Porphyromonas gingivalis can inhibit the movement of neutrophils. It's commonly seen in disease sites that are worsening. So, Porphyromonas gingivalis is associated with perio, and it basically attacks the immune system and stops neutrophils from migrating to the area of infection or inflammation. You can see Porphyromonas gingivalis in recurrent and refractory disease. So those were the 4 bacteria. AA, FN, TF, I think, and Porphyromonas gingivalis. So, periodontal diseases are mixed infections. AA, PG, and TF, those bacteria, extensively are studied and are strongly implicated in periodontitis. But remember, all perio infections are caused by multiple diseases. These are just the most common ones we see. There's a few other bacteria we should be aware of. Prevotella intermedia. This is bacteria associated with hormones, like we talked about earlier. When you think of Prevotella, you think of prego, and prego person has lots of hormones, and they can be affected. And then Campylobacter rectus. Excuse me. Which is also associated with pregnancy, because remember we thought of it this way. A pregnant person names their child Philo, or you got pregnant at summer camp, Campylobacter. It's associated with pregnancy. But most importantly, out of all these bacteria that we talked about, what is the most common one? It's Poromonas gingivalis. Alright. Let's see here. Transmission of periodontal pathogens. Periodontal pathogens are easily transmittable. They can be transmitted from the mouth of you to the mouth of another person, which is why kissing is the primary way saliva and its bacteria contents are mixed around to different people. This is also important because it can happen between parents and children in sharing spoons or straws. So that's important to remember. However, little to no evidence supports the fact that periodontal infections are communicable, which means we're not sure if perio can be passed from one person to another by indirect or direct contact. Alright, and that's part 1 of biofilm and periodontal infections.